We now determine the values of p so that the angle between the two vectors is given as theta equals cosine inverse of 4 over 21. So according to the dot product rule, we can write down angle between two vectors, that is a vector and b vector. The angle between these two vectors is given by the formula cosine theta. This equals the dot product of the two vectors, that is a vector dot b vector divided by the product of the magnitudes of two vectors, that is magnitude of a times the magnitude of b vector. So this is the formula to find the angle between the two vectors a vector and b vector. And therefore for these two vectors x vector and y vector, we can utilize this formula. That is I'm going to write cosine theta. This is the formula we use to determine the angle between the two vectors. So we write here we have two vectors, so we find the dot product of x vector with y vector that goes to the numerator, and in the denominator we write the product of their magnitudes, that is x vector. We find the magnitude of x vector, multiply this with the magnitude of the y vector. So let's evaluate both the numerator and denominator expressions. First, let's evaluate the dot product of these two vectors. So I write x vector dot with y vector. And this equals, let's replace x vector by negative 4p and negative 2. And this must be dot with y vector, which is negative 2, 3, and 6. And in dot product, we find the product of the corresponding components and add them together. So it is negative 4 times negative 2 equals positive 8. We then add this with the other products, that is p times 3 is 3p. We then add this with the last product, that is negative 2 times positive 6 is negative 12. So I'm going to write this as negative 12. Let's simplify this. So here we get 3p. Write this first. 8 minus 12 is minus 4. So this is the result of the dot product x vector and y vector. Now let's find the magnitude of x vector and y vector. The magnitude of x vector, we write down this as the square root of the sum of the squares of the components. So let me copy the x vector. X vector equals negative 4p negative 2. This one is negative 4p negative 2, and y vector equals negative 2 3 6. So let's determine the magnitude of x vector. We take the squares of the components and add them together inside the square root. So it is negative 4 square plus p square plus negative 2 square. And so simplifying this, we get this is under the square root. Negative 4 square is 16 plus p square plus negative 2 square is 4. Simplifying this, we get 16 plus 4 is 20. So this is square root of 20 plus p square. This is the magnitude of x vector. Now let's find the magnitude of y vector in the same way. And so here we write the square root of the sum of the squares of the components. So it is negative 2 square plus the next component is 3 square, and then the next component is 6, so it is 6 square. Simplifying this, we get a negative 2 square is 4 plus 9 plus 6 square is 36. And so adding them together, this equals 36 plus 4 is 40. 40 plus 9 is 49, and we take the square root. And so this equals 7. Okay, so since we have determined the x dot y, the magnitudes of x vector and y vector, we can plug it into the cosine theta formula. So let's do that. So therefore, we write cosine theta. This equals, in the numerator, we replace x dot y as 3p minus 4. So this one is 3p minus 4, and in the denominator We write the product of the magnitudes of the x vector and y vector. The magnitude of x vector is square root of 20 plus p square, and the magnitude of y vector is 7. So this must be multiplied, sorry for that, this must be multiplied with the 7, or else we can write this as 3p minus 4 divided by 7 times of this is square root of 20 plus p squared. This is cosine theta. Now to determine the angle theta, we apply cosine inverse on both sides, and doing so we get theta equals cosine inverse of 3p minus 4 divided by 7 times of 20 plus p squared under the root. So this is the expression for the theta we get when we use the formula. We will now see how to determine the value of p using the theta which we found using the formula, as well as the theta which is given as part of this question. Now we have two expressions for theta, this one using the formula and this one is given as part of this question. So therefore these must be the same, that is the right side expression must be the same. The right side expression is we have cosine inverse and we also have cosine inverse, which means the expression inside the cosine inverse must be the same, so that we get the same value for theta. And so we can write down the expression 3p minus 4 divided by 7 times of square root of 20 plus p squared, and this equals the expression in this cosine inverse is 4 over 21. So we can simplify this, or we have to write this in the form such that we get the variable on the one side and the numbers on the right side. Since we have a square root in the denominator of the left side, we are going to square both sides of the expression. That is, we square it up on both sides, and when we do so, we will have the square of the numerator term, which is 3p minus 4 quantity square, divided by the square of the denominator expression. The square of 7 is 49. And then when we square this square root expression, the square root will cancel or it will go off. And so this equals the square of 4 in the numerator is 16. And then the square of 21 is 441. Now let's do the cross multiplication and put this in a simple form. So we have to do the cross multiplication of the terms like this. That is, this will become 441 times 3p minus 420 squared, and this equals 16 times 49 times 20 plus p squared. And so we can simplify this and put this expression in a quadratic expression, because this one is a binomial square. We have the term 3p. So when we square using the binomial identity, we will have a 9p square here, and we will have another p square term over here, and then we will also have some constants, and then we'll also have a variable p. So simplifying everything, we will get this quadratic equation, that is 3185 p square minus 1000, I'm sorry, it is 10,584p minus 8,624 equals 0. So this is the quadratic equation which we get after we do the simplification of this expression or this equation. This is basically a quadratic equation which can be solved by using the quadratic formula. That is, we use the formula negative b plus or minus square root of b squared minus 4ac over 2a, where a is the coefficient of p squared and b is the coefficient of p, and c is the constant term negative 8624. And so when we plug in all this a, b, and c into this quadratic formula and finally solving for p, we get two values for p, that is p equals 4 or p equals negative 44 by 65. And so these are the two values of p given that two vectors and the angle between the two vectors.